Hopefully by now you've had an opportunity to attempt the first exam question on analytical techniques. I'm going to work through this exam question just so you can compare your response to what I would have done had I been in an exam situation. So we're told that alcohol E is one of the following 6 alcohols. We're then told that alcohol E is oxidised by heating under reflux with excess acidified potassium dichromate solution to make F. We've got the mass spectrum of E and we've got the infrared spectrum of F. It's highly likely we're going to have to identify what E and F are. When you look at this question, you can see we've got a variety of different alcohols. We're going to be asked to draw out those alcohols, and we're going to be asked to identify E and F. So, here are our structures. I've drawn these out for you. I've tried to draw them in a variety of different ways. You could have drawn them skeletally, you could have drawn them fully displayed. It doesn't really matter. What I've also done is work out the MR of each of the molecules, and I've popped that at the side. We can see that we've got 2 with the same MR of 60 and 2 with the same MR of 74. What we're asked to do in part 2 of the exam is to identify alcohol E and then F and explain our reasoning in full. Well, when we look at the evidence, starting with the mass spectrum, if you remember, a mass spectrum can tell us lots of things, but the most important thing is to tell us the MR of the molecule. And what I'm going to be looking for is not this tallest peak, but the peak which is furthest up the MZ axis. And I can see that with an MZ of 60, I have a peak which corresponds to the molecular ion peak. And that's telling me the MR of the molecule. So I'm clearly only going to be interested in propan 1-ol or propan 2-ol. E could only be propan 1-ol or propan 2-ol because these both have an MR of 60. There's a molecular ion with an MZ of 60, and that's telling me the MR of the molecule. I don't know which one of those 2 molecules it is until I start looking at the infrared spectrum. Now, when we were discussing infrared spectra, we talked about the idea of identifying the presence of OH bonds in alcohols, OH bonds in carboxylic acids, and CO double bonds in aldehydes, ketones, or carboxylic acids. OH bonds are usually broad and in this region. Clearly, F does not contain an OH bond because there is no absorbance in the corresponding region up here. So this is clearly not a carboxylic acid. Now, when we oxidise alcohols, if we were to oxidise a primary alcohol, we can form 2 things, either an aldehyde or a carboxylic acid. If we oxidise a secondary alcohol, we'll form a ketone. This is not the infrared of a carboxylic acid. But we can see here we've got this absorbance around about 1700. That's telling me that I've got the CO double bond present. Now, C double bond O, we know it's not a carboxylic acid. It could be an aldehyde or a ketone. So when I look at the question, identify F and explain my reasoning. How do I know whether I'm dealing with an aldehyde or a ketone? Well, going back to the question and reading it carefully, I am oxidising my alcohol E, which I know is either primary or secondary, under the reflux conditions. Now, if I took a primary alcohol and did a reflux oxidation, I would make a carboxylic acid. This is not a carboxylic acid. So I must have started with my secondary alcohol. So E must be propan-2-ol. It can't be propan-1-ol because if I'd done oxidation under reflux conditions, I would have got a carboxylic acid. And I would expect to see an absorbance, a broad absorbance in this region, and that is not present. Okay? So that tells me the answer to part 1 and part 2. An equation for the oxidation of alcohol E with acidified potassium dichromate. Well, we know we've started with propan-2-ol. So let's start propan-2-ol. And I'm going to oxidise that. I'm going to use O in square brackets to represent my oxidising agent. The oxidising agent removes 2 hydrogens to make a water molecule, which leaves me with this molecule, a ketone with 3 carbons, prop and one.